that we are reviewing is because before spring break, I know there were a lot of people that are absent, and we just have to kind of have one day to like get back on the same page. So your test will be on Thursday. If you are not aware, Tuesday it's a B day, but you actually will come see me, but I don't see my first period, and I'm gonna have y'all both test on Thursday. So the way that that day is gonna look is that you're gonna come to school still at 9 a.m. for some terrible, tragic reason. You're gonna sit in a holding room until like 11. Then you'll go to a meeting, and then you won't go to fifth period until 2 p.m. So if you don't come that day, which I'm kind of anticipating some of you might not, I don't want to give that test that day and then be trying to make everyone take it later. So your test is on Thursday. Tuesday will be somewhat of a free day, and it covers the following topics. So let's get started with the first one. Okay, you have dy dx equal to 2 sine x times y. Now, this is called a differential equation because it's an equation for a derivative. So I'm going to turn this light off so I don't have a glare. So in order for me to go back to y, I have to take an antiderivative. So before you do that, you're going to separate. Then you're going to do the antiderivative. Then you're going to solve for y. And you should have this in your notes if you haven't been absent. And then you're going to find your c. Okay, so those are kind of your general steps for solving differential equations if you kind of don't remember how to do this. So first question, I see that I have a times y on the right. I am going to divide by y on both sides. And since I don't have anything to divide over here, I'm just going to put a 1 on top. So my y is gone off the right, it's only on the left. How do I get rid of my dx, which is divided? Multiply a dx. So gone, gone. So now I have 1 over y dy, and then 2 sine x dx. So the first thing I did is separate. Next thing I'm going to do is the antiderivative. So integral, integral. 1 over y is special. What's the integral of 1 over y? ln y. Okay, technically you should have absolute value bars around your y. What is the antiderivative of 2 sine? So remember, snow cone, but you're trying to go up. So if you're already at sine, you have to loop back around, it's -2 cosine. Okay, then don't forget plus c. How do I get rid of the ln in the front to get the y alone? Not divide, e. So I have absolute value y equals e to the -2 cosine x plus c. And then to get rid of the absolute value bars, remember you just apply a plus or minus to the other side. So it would be y equals plus or minus e to the power of -2 cosine x plus c. Okay, that is called your general solution. And the reason it's called a general solution is because you don't know what the c is yet. So in order to go from a general solution to a particular solution, which is what they're asking you to find in the question, you're going to need to use the initial condition that they gave you right here. So it says y of pi thirds is -2. Then that means that -2 is the answer when I plug in pi thirds. So this is the x, this is the y. So -2 is the answer on plus or minus e to the -2 cosine pi thirds plus c. First question, am I going to pick the plus or the minus to match the y value that they gave me? This is a -2, then I want to pick the minus as well. So I have -2 equals minus e to the -2, and now I need to know what cosine pi thirds is. So pi thirds is which finger? 0, pi 6, pi 4th, pi 3rd. So it's right next to your thumb. It's your pointer finger. Okay, then cosine are the fingers up. How many are up? So it's 1/2. So I have -2 times 1/2. What's that exponent going to be? -1 plus c. Now, because both sides have this negative, I'm just going to cross it out. Okay, so if it's a negative in front on both sides, you just times by -1 and then it's gone. Okay, from here, I need to get my c out of this exponent. How do I get rid of an e base? ln both sides. ln and e cross out. So I have -1 plus c equals the natural log of 2. And then to solve, how do I get rid of the -1? +1 on both sides. Which means my c is the natural log of 2 plus 1. Okay, and then remember, you're not done until you've taken that c and rewritten your particular solution with that number plugged in. So let's write that right here. It's going to be y equals, we chose the negative in the front, 2 cosine x plus ln 2 plus 1. And that would be your particular solution. Okay. Now, the other hope that I have with us reviewing today is that if you haven't finished this homework, I gave it to you before spring break, but hopefully you'll have some refreshed memory on how to do it. Go ahead and turn the page. So 1 and 2 are very similar. Okay, 3 and 4 are also very similar. So go ahead and separate. Okay, for number 3, your dy dx is a y squared over x. And I noticed that my y squared is multiplied. So how will I move it across to the other side? Divide it. So it'll be a 1 over y squared dy. And then an x dx. Is that right? No, the x was where? And even if the y squared goes away, the x needs to have something on top, so just put a 1 there. Okay, then integral. Now, one of these is special. 1 over x has its own special rule. What's the antiderivative? Natural log absolute value x plus c. Okay, however, this is not an ln, and here's why. It's not 1 over y, it's 1 over y with a power. So I need to take my y squared and rewrite it as a power. What power will I use? Y to the -2. Very good. Okay, remember, if it's just a 1 over y, you can ln it. But if it's got a power with it, you got to rewrite. So add 1 to that. What is -2 plus 1? Y to the -1. And then I have to divide by -1, so I'm just going to put a minus in the front. Now, y to the -1 can be rewritten as 1 over y. So go ahead and do that for me. Okay, but if you have a power that's negative, that means you can push that y to the first power down into the denominator. And then how can I get rid of this negative right here in the front? If it's a times -1, I could just times by -1 again. And that'll cancel it out. So now this is just 1 over y. And this is a negative ln x. And then remember the c you don't really care about. Okay, when we get to here, how do we get the y out of the bottom? Don't multiply. You could, but don't. We want to flip both sides. And if I want to flip this side, I need something on the bottom. So I'm just going to put that whole side over 1. So my general solution is going to be y equals 1 over the negative natural log of x plus c. Okay, so I'm going to put here, flip both sides. Okay, if you need to get y by itself and it's under a 1, just flip. Okay, from there, we're going to use our particular solution. Okay, it says y of e is 1. Then what am I going to plug in the y spot? Hold on, using this point. Which number goes in as the y?
Oh,
The 1. And then the x will go in as an e. But what is going to happen with an ln and an e? Cancel out to what? Not 0, 1. So that's a -1 plus c. And then I noticed that the c I'm trying to solve for is on the bottom, so I'm just going to flip both sides again. Now, if this is a 1, and I put it over 1, and I flip it, what's going to happen? What is 1 over 1 if you flip it? Still 1. So I have 1 equals -1 plus c. Add that 1 across, what's my c going to be? +1 though. So it'd be 2. Okay, and then from there, don't forget, this is my general solution. When I change that c to a 2, then it's my particular solution. So it'd be y equals 1 over -ln x plus 2. Okay, and you'll work the question below that very similarly to the way that we worked that. Go ahead and turn the page. All right, next one, go ahead and separate the y and the x. They're currently multiplied. So just like the other two, my y cubed is going to end up as a 1 over y cubed. And then my x cubed dx is going to just kind of stay put. Technically, the dx, I guess, did move over. After I separate, what's step 2? Do the thingy. Yep. Okay, integral or antiderivative. Let's do the x side first. If it's an x cubed, what's the antiderivative of that? So we're going to add 1 to the power, then divide. So x goes to the 4th, then a 1/4 plus c. On the 1 over y cubed, can I ln it? No, because it's got a power. So I'm going to have to rewrite that if that's a y to the -3, because it's on the bottom, what's going to happen when I add 1 to that? -3 plus 1 is going to be y to the -2. And then divide by -2. So I'll put a -1/2 in front. Okay, keep in mind, if there's not already a number in front, you're just dividing it with a 1. Now, my goal is to get this y by itself. So how can I undo a divided by -2? How can I cancel that out? Multiply by -2 all the way across. Remember that technically you are multiplying by the c, but since you don't know what it is, we're not going to keep track of that. So my -2 multiply, -2 divider gone. I have y -2 equals. What is -2 times a 4th? 1/2, yeah. And then x4 plus c. Okay, then remember, I can't solve it with this y with a -2, so I need to rewrite that where my y squared is going to get pushed down to where? The bottom. So it'll be a 1 over y squared, and then this stuff. What is my next step if I'm trying to solve for y and it's on the bottom? Flip both sides. And what if the right side isn't a fraction? Put the whole thing over 1 so you have something to flip it with. So this is going to go to y squared, and this is going to go to 1 over -1/2 x4 plus c. Okay, we're almost done. What's the next step? Square root, square root. Now, technically, when you square root a fraction, you need to do the top and the bottom. But what is the square root of 1? still 1. So I'm not even gonna bother to put it up there. Okay, but when you take the square root of a fraction, you would do the top and the bottom. What else do I need to remember to write in the front? Plus or minus. So my general solution is y equals plus or minus 1 over the square root of negative a half x4 plus c. Look for your initial condition. It should be an XY combo that will allow me to find my C. So they tell me right here that my Y of 2 is 1. Which of those numbers is the Y? 1, and then that should be the answer when I plug in 2. Okay, let's do this little plus minus situation in the front. Remember, I want to pick the answer that matches the Y value they gave me. So if they gave me a positive 1Y, I'm picking the positive. Okay, then down here, I need 2 to the 4th. So that's 2 times itself 4 times. 2 times 2 is 4 times 2 again. Times 2 again, 16. Okay, now I need to take that 16 and cut it in half. So what is that going to come out to be? Okay, square root negative 8 plus c. Okay, from here, I notice my c's on the bottom. That means I'm going to flip both sides. But remember, it's kind of nice when this is a 1, because when I flip it, it's basically just going to stay a 1. So we're going to flip both sides. 1 over 1 is still 1, and now this is negative 8 plus c under a square root. What do we do next? Square, square. 1 squared is still a 1, but now my square root is gone. I just have a negative 8 plus c. Then from there, add that 8 across. What will my c be? 9. Okay, then remember your particular solution. You have to plug in the 9 and choose the plus or the minus. In this case, we know that we chose the plus. Okay, but if you're picking the minus, you would need to make sure to write it. All right, any questions on how to do those? Yes.
How do you choose between the plus and the minus?
You choose based on the point that they gave you. So if they give you a Y value that's positive, you need your answer to be positive as well. Versus if you look at the first example, they gave me a Y value that was negative. So that let me know that I need to choose the negative. Okay. All right. Let's go down to the next question. So it says the quantity of a substance can be modeled by the function h. Then it says differential equation dH dt equal to that. Remember, all that means is an equation with a derivative in it. 1 point on this function is h1 of 70. And then it says, based on this model, use a linear approximation at the graph of h at 1 to estimate t of 0.8. Linear approximation means you're going to write the equation of the tangent line. And then you're going to plug in the decimal that they give you. Okay. So, what are the 2 ingredients that you need to write an equation of a tangent line? Point and a slope. Look in the problem. What point did they give you? Right here, 170. The 1 in the parentheses is the x. The 70 is the y. So it's 1 comma 70. And then when I want the slope, I need to plug into the derivative. But remember, that's what a differential equation is. So in order for me to find the slope, I'm going to plug into dH dt. And dH dt vertical line 170 means that I'm gonna plug in this point to this equation. Now, how many variables are in the equation? Only one. They want the H. Is that the X or the Y? Y. Here's how you can know. Think dy, dx. dy is where the H is. dx is where the T is. So if they're wanting negative a tenth of H, they're wanting negative a tenth of 70. Sometimes you'll be using the X and the Y. In this case, though, there's only a H, there's not a T in. And then what is that number? Negative 7. Let's write the equation of our tangent line. Y blank equals blank X blank. Remember, the X and the Y are going to go in as opposites. The slope will go in with its true sign. So my slope is a negative 7. My X is going to be a -1. My Y is a minus 70. And then remember, after I write the equation of the tangent line, I need to plug in the decimal they want. What T am I plugging in? 0.8 will go right here. So what is 0.8 minus 1? 0.2. Okay, then what is 2 times 7? 2 times 7 is 14, and then just put the decimal back, it'd be 1.4. Okay, so 2 times 7 is 14, but then I would just put the decimal back one spot over. Okay, also it is negative. Oh, you're right, it is negative, thank you. Okay, because if it's 0.8 minus 1, this should have been a negative, which means now how's this going to come out when I multiply these? Positive. Thank you. Then we have a minus 70. We need to add that across. 1.4 plus 70 is going to be 71 point. Okay. Questions on that? All right, turn the page. Okay, the next two questions are pretty similar. We're going to do the one at the very bottom of that page, number 10. Okay, so you have a graph of f, and then it's asking you to find this integral right here. Okay, procedurally, tell me if this is correct. If I want the integral of f plus 3, I can just do the integral and then add 3. Yes or no? Okay, no. If you have a plus 3, remember that you need to break that down into 2 separate integrals. So you'll do the integral of f and then the integral on the 3. Okay, so you're going to break that into 2 separate pieces. Now, for this part, the graph of f is going to be super helpful. So look at your graph, shade from -2 to 6. So -2 is here, all the way till 6 is here. I'm going to get this area, and this area. So 5 and 8 on the bottom is 13. Take away from 11. How much area am I going to keep when I minus those? So 13 take away 11 would be 2. Now let's talk about the sign. Technically, more of the area is below, right? That the 13 units are on the bottom, so it should come out to be a -2. Will it be a -2 here? No, because what about the endpoints? They're backwards, they're out of order. So this is going to count as a +2 because not only is the area below, but it's also backwards. Okay, for this one, you're doing fundamental theorem. So remember, you're going to take the antiderivative of 3, which should be pretty easy. What's the antiderivative of 3? 3x. Remember, technically there's a plus c, but it always crosses out, so you don't really have to write it. Then we're going to plug in the top and the bottom, and then we're going to subtract. Let's do -3 first. -3 plugs into 3x. What do I get? -9. Technically, plus C. Now plug in your 6. 6 plugged into the 3x is going to give me 18 plus C. And then remember, it's this minus that. What's negative 9 minus 18? Negative 27.
It's supposed to be a -2.
No! Is it? Yeah. I don't know why I put a 3 here. Sorry. Thank you. So this is a 2. So then what is our 9 now? 6. And then negative 6 minus 18, that'd now be a 20. Thank you. And then 2 minus 24, final answer. Negative 22. Does that look good now? Okay. Now, one thing first period asked that I thought was a good question was they had said, well, if this is backwards, why don't we switch it? Okay, if it's fundamental theorem, you don't have to worry about that. If you're dealing with a graph, think about it. Okay, but if you're doing fundamental theorem, as long as you keep them where they are, the answer is going to come out right. Okay, all right, turn the page. All the way to the very back. Yeah, you don't have anything else besides this packet. All right, so this is a graph. This is a graph of f of x. Okay, and then if you will, please, in part A, these should all be g's. I made this kind of in a hurry yesterday. So relabel, we're looking for g of 5, g prime of 5, and g double prime of 5. Now, before I go through and find those, okay, I'm going to do exactly what we did last class, okay, which is that I'm going to write them up here in the top corner, and I'm going to find g, g prime, and g double prime, okay? So let's do that first. G of x is defined right here. It is the integral starting at -3 and stopping at x on the function f of t, which I have a graph of. What will g prime be using the fundamental theorem? That if I take the derivative of an antiderivative, they cross out and I just do a letter swap. So my x is going to go here and I'm just going to want f of x. What will g double prime be? F will go to f prime of x. Very good. And then if you don't remember what features those are, the integral is area. Regular f is the y value. And f prime is the slope. Okay. So go ahead and find these 3 now for part A. So we're looking for g of 5, g prime of 5, g double prime of 5. So g of 5, I'm plugging the 5 in where the x is. And I see that it's the top endpoint. So on my graph, I'm only going to shade starting at -3 and then stopping at 5. So -3 is here, 5 is here. We want all of that. What will the net area be? 8. Will I count it as a positive or a negative? It'll be positive because not only is most of the area above, but it also is already in the correct order. Okay, g prime of 5. Remember, g prime is really f, which is the y value. So I want the f at 5, which is what number? 0. And then I want g double prime of 5. That would be f prime of 5, which would be the slope. And if you look at the graph at 5, you should be able to tell that at that point, the slope is flat. So that would be what slope? 0. Now, one more thing I'm going to add is that remember, they can only ask you to count the slope out by hand if it's a straight line or if it's flat. Okay. So remember, rise over run for that usually. Okay, next part says, what is this should say maximum value of the function on -7 to 5. Okay, and then let me also say that if it doesn't say relative, thank you. Okay, Aubrey, you're going home. If it doesn't say relative, it means absolute. Okay? Have a good weekend. Okay, so go ahead and write in there that if they don't say relative, they mean absolute. And for absolute maxes, you need to make what we call a candidates chart. So make yourself a little chart here. The things that go in the chart are the endpoints and the critical numbers. So let's start with the endpoints. We're only going from -7 to 5. Okay, -7 to 5, and then look at your graph and place dots on all the critical numbers. Okay, remember that critical numbers are where G prime equals 0, which means the Y values need to be 0, so they should be all these x-intercepts. Now, out of all of those 4 choices, which of them actually pass through the x-axis and are not a neither? Just 2. So the bounces on the x-axis, they are critical numbers, but since they're not a min or a max, I'm not going to put them in my chart. So just put 2 here. Now, next question, is 2 the right type? Is it a max? Because it passes through how? From plus to minus, that makes it a max. Okay, then in your candidates chart, once you identify your candidates, you're going to find the Y values. Which of these Y values did I already find in part A? G of 5 is what? 8. So we don't need to find that. We already know. Okay, that regular G of X is 8. So that leaves me with 2 left to find. I'm going to find G of -7 and then G of 2. Both of these are going to be integrals starting at -3 using the graph that I have shown. So first, let's do the -7. From -3 to -7, how much area am I going to trap? 11, and the 11 units are above the x-axis. Will this be a positive 11? No, because the order is backwards. Okay, from -3 to 2, that'd be from here to here. I'm trapping 18 units of area. Will it be positive or negative? Positive. And then out of those 3 Y values, which one is the biggest for the maximum? 18. So I'm going to put the absolute max is 18, and it occurs at x equals 2. Okay. All right, last question like that. It says, on what intervals is the graph of G concave down and increasing? What G, original G, G prime, or G double prime, deals with concavity? Okay, concave down is which one? G, G prime, or G double prime? Okay, G double prime, and it needs to be negative. Now, let's think about for a second, if G double prime is negative, what feature is that? This slope. So I'm going to put, okay, the slope of the graph I'm looking at needs to be negative. Okay, now I also want G to be increasing. For G to be increasing, is that about G, G prime, or G double prime? G increasing is which one? G prime. And it needs to be positive. But then I would think to myself, I don't have a graph of G prime, I have a graph of F. And on the graph of F, what feature is G prime? Y value, which means if I want a positive Y value, I need to be above the x-axis. So now look on your graph. Where am I above the x-axis? And I have a slope that's negative. -5 to -3, that's one of them. 0 to 2 is one of them. There's one more. -10 to -6. Very good. Okay.
It looks like -9.
Oh, yeah, you're right. We'll call it 9. Okay. All right, the very last problem we're gonna do is B. Okay, and then you'll have the rest of class to finish. B gives you a function f and it asks you to find f prime. What are they asking you to take? If I have f and I want to find f prime, what are they asking me to take? A derivative. A derivative of a what? Antiderivative. And when I take the derivative of an antiderivative, remember they cancel out and I do a letter swap. So all of my t's are going to go in as 4x's. So instead of 8 over t squared plus t, now it's going to be 4x squared plus 4x to the 5th. Okay, so remember, a derivative of an antiderivative, you switch out the t's for 4x's. And then remember, we want to algebraically kind of clean that up. What is 4x if you square it? You have to square both. That's 4x times 4x again. It would be what? 16x squared. And then the second 4x, I'm just going to leave it grouped to the 5th. If you don't need chain rule, that is the correct answer. You need chain rule anytime that your letter swap is more than just an x. What is it here? A 4x that I need to do chain rule. What am I going to times by? The derivative of 4x is an extra times 4. And then 8 times 4, let's make that a 32. Okay, and that would be your answer. Okay, so your test, okay, it won't be 2 days back to back, it'll be just 1 day. But it'll cover just this. I did not put slope fields on this test. We'll circle back to that later. So let's get to work. You can do it.
Fine.